So now we're going to look at the derivatives of composite functions. But before we look at the derivative, let's talk a little bit about composite functions. So a way of combining functions is through a process called composition. And so what is a composite function? Well, given two functions f and g, the composite function f follows g, so that open circle represents the word follows, is defined by f follows g is equal to f of g of x. So we're saying the function g of x is inside or replaces all the x values for the function f of x. So let's take a look at a few examples. So if f of x equals the root of x plus 1 and g of x equals 3x squared plus 5x, let's evaluate each of the following. So let's start with f of g of 1. So first of all, we need to determine the value of g of 1. We start with the inside. And g of 1 would be taking the function 3x squared plus 5x and subbing in the value of 1. So that'd be 3 times 1 squared plus 5 times 1, which gives us a value of 8. So now we need to evaluate f of 8. So now we're going to take the value of g of 1, which is 8, sub it into the function f of x. So f of 8 would be the square root of 8 plus 1, which is equal to 3. Second one, g follows, or g of f of 3. Well, that's equal to g of something, and what we need to determine is, first of all, f at 3. Well, f at 3 would be the root of 3 plus 1, which is equal to 2. So we need to evaluate g at 2. And g at 2, that's going to be 3 times 2 squared plus 5 times 2. And that's going to give us 22. Finally, what about g of f of x? This is saying that we're going to take the function f of x and sub it in for all x values for g. So what we have is the following. We want to find g of the root of x plus 1. And that's equal to 3 times x plus 1 squared, the root of x plus 1 squared, plus 5 times the root of x plus 1. If we simplify, we end up with 3 times x plus 1 plus 5 times the root of x plus 1. And when we determine composite functions, we should always state a domain. So in this example, x must be greater than or equal to -1. So our final derivative shortcut for this unit is the chain rule. And the chain rule states the following. If f and g are functions that have derivatives, then the composite function, f follows g, has the derivative f prime g of x times g prime of x. So another way to think about this is that I'm going to take the derivative of the outside function, then times it by the derivative of the inside function. And with the outside function, I'm going to let x equal g of x. So let's go through a few examples using the chain rule. So first example, what is the derivative of the root of 4 minus x squared? When you're starting using the chain rule, you should always identify the outer function versus the inner function. And for this example, the outer function f is equal to the root of x, and the inner function g is equal to 4 minus x squared. And that is making the assumption that h of x is equal to f of g of x. Secondly, I would determine the derivative for both the inner and outer functions. So f prime of x, and this one we've seen a few times, that's 1 over 2 root x. And the derivative for g is just going to be -2x. So let's go through the derivative here. So dy over dx is the derivative of the outer function. So that's this here. So that's equal to 1 over 2 root of, but remember it's the derivative of the outer function where x is equal to g of x. So this would be 4 minus x squared. Then times the derivative of the inner function, 4 minus x squared, which is -2x. We can simplify this and we get -x over the root of 4 minus x squared. And we're done. With more practice, you won't need to include any of this information here. So let's go to the next one. So we have an outer function and we have an inner function. So for this one, I see that my outer function f is equal to x to the exponent 6. And my inner function g is equal to 3x to the 4th minus 5. The derivative of x to the 6 is 6x to the exponent of 5, and the derivative of g is 12x cubed. Alright, so let's take the derivative of h prime of x. It is the derivative of f prime of g of x, so f prime is 6. And then we're going to sub in g of x, and g of x is 3x to the 4th minus 5, times the derivative of the inside function, which is 12x cubed. And again, if we wish to simplify this, that's 72x cubed times 3x to the exponent 4 minus 5 to the exponent of 5. And we're done. Next one, let's change this to f here, maybe to make this a bit easier. We have our outer function, which is f of x. We have our inner function, which is 5x squared. So what's the derivative of f of x? Well, that's just f prime of x. And what's the derivative of 5x squared? That is 10x. So this derivative here, so h prime of x, is equal to, well, it's f prime of whatever g of x is, so this is 5x squared, times the derivative of the inside, which is 10x. And again, we could rewrite it like this. And we're done. Next one, a little bit more complex. We have a function times a function, so we're going to need our product rule. So imagine that is p and that is q. So if I want d prime of t, what does that equal? I know it's got to equal p prime q plus p q prime using our product rule. So let's start with the derivative for t. The derivative of t with respect to t is equal to 1 times function q, so that's the root of v of t, plus t times the derivative of the root of v. Well, the root of v, think of it this way, it's the root of x is your outer function, so I know that derivative is 1 over 2 root x. So this is going to be 1 over 2, but instead of being x, it's going to be v of t, because it's a composition of functions, then times the derivative of the inner function, which is v of t, so this is v prime of t. So this simplifies to the root of v of t plus t times v prime of t all over 2 times the root of v of t. And I'm not going to simplify this any further, but there would be the derivative for this function. And the final one, e, f prime of x. This one, we're just going to take the derivative of each of these independently. So this is 2 times the derivative of g of x cubed. So using our chain rule, or in fact our power of a function rule, this is 3 g of x all squared times the derivative of the inside, that's g prime of x, plus 3, the derivative of g of x is g prime of x, plus 0. And you see we end up with 6 times g of x all squared times g prime of x plus 3 times g prime of x. And we're going to use this derivative to help us answer the final question. Determine the equation of the tangent for f of x equals the following function, and that's the one from part E, at x equals 1. So first off, let's determine the derivative for f of x. And we note from example E that the derivative is equal to 6 g of x squared times g prime of x plus 3 times g prime of x. So let's determine the slope of the tangent at x equals 1. And from our table, we see that g of 1 is equal to 2, and g prime of 1 is equal to 4. So therefore our slope is equal to, and that gives us a slope of 88. That is the slope of the tangent line. Now we need the point of tangency, and we note that the x value is 1, and the y value we can determine by subbing in 1 for every x value in our original function. And again, g of 1 is equal to 2. And if you sub that in, you get a value of 23. So therefore, we have y is equal to 88x plus b. Subbing in our point of tangency, we get 23 is equal to 88 plus b, and therefore b is equal to negative 65. So therefore, the slope of our tangent line is y equals 88x minus 65 at x equals 1. So try the following questions from your book. And then I'd also like you to try the following question. Prove that the derivative of the absolute value of x can be expressed as x over the root of x. And to do that, you're going to let the absolute value of x equal the square root of x squared and then take the derivative of that function. And hopefully you can see how the root of x squared is equivalent to the absolute value of x. Good luck.